Event in aviation history is taking place here at one of the huge hangars of Air Force Plant 42 in Palmdale, California. This is the first showing of the most spectacular airplane ever developed in America, the triple-sonic Xb70A. The skies are sunny, and the weather is warm this May morning. Attendees include a few members of Congress, the Air Force, Department of Defense, the press, local officials, and the men and women who actually built the airplane. Among the dignitaries we observe are Major General Robert G. Ruig, Brigadier General Fred J. Ascani, and Lee Atwood, President of North American Aviation. We see him meeting visiting members of Congress. Roscoe Turner, a pioneer in aviation, is on hand. And that is Al White, chief pilot for North American, the man slated to fly the plane. And now, for the Air Force, General Ruig gives the introductory address.
Thank you. Ladies and gentlemen, it's with great pleasure, both personally and on behalf of the United States Air Force, to welcome you to this very important event. I think before proceeding farther, I would like to acknowledge just a few of our distinguished visitors this morning. Congress, Senator Howard Cannon, Congressman Everett Burkhalter, Congressman Jeffrey Cohelan, and Congressman Bob Wilson. The Xb70 is part of a program aimed at the development of technology of Mach 3 flight. Its rollout this morning represents a very significant step forward in that quest for advanced aeronautical knowledge. An experimental airplane, the Xb70 posed many technical problems and challenges, especially so because we are probing the furthest reaches of aeronautical flight. Some of the problems were unprecedented and most difficult to solve. They involved many aspects of development and fabrication. Embodied in the Xb70 is the technical knowledge needed to take other steps forward. And the history of aviation has long followed this pattern. And from it, we gain the foundation of knowledge upon which all of our progress in the air is based. I want to congratulate the men and women of the North American Aviation Company whose skills and labors have fashioned this airplane, the men and women of the General Electric Company at Avondale, Ohio, the plant who furnished the YJ93 turbojet engines with which it's powered, and those are the many subcontractors and suppliers who have given the B-70 their time and talent. I would also like at this time to acknowledge the hardworking members of my own outfit, the B-70 System Program Office, who share this event with you. And now, if I can find the button, I've got it here. Now to tell you about this airplane as it rolls out, we'll describe some of its features. It's the Deputy Commander for the B-70, General Fred J. Ascani. General Ascani.
I'd like to take, with your indulgence, just a second or two to regain my composure. It's been a long time getting to where we are today, and I'll be perfectly candid and admit that when those doors started to open, I choked up just a little bit. I'd like to cover some of the brief points that will be obvious to you as we proceed with the rollout event. In the general category, you'll be looking at an airplane that is approximately 184 feet long with the special instrumentation on the nose. It runs approximately 196 feet. The wingspan is about 105 feet, and to the top of the vertical fins, the height is approximately 31 feet. The weight is much greater than that of a B-52 in our latest configuration. The nose section, as it starts to emerge from the building, is built entirely of titanium. There are over 12,000 pounds of titanium in this airplane. The two-man crew will sit side by side. The crew station in this position is about 20 feet above the ground. At touchdown during landing, the pilot will be about 30 feet above the ground, and he'll be approximately 110 feet ahead of the main landing gear. One of the novel features of this airplane is the movable windshield and nose ramp. It moves to a ferret position, streamlined, to reduce drag at very high speed. The white paint you see applied to the entire air vehicle is there to reflect some of the heat from the 450 to 630 degree Fahrenheit airstream that we will encounter at Mach 3. Even with this protection, the fuel carried aboard the Xb70 is required to absorb heat at a rate that would keep 46-room houses warm in the coldest Minnesota winter. All of the space aft of the crew compartment is taken up by fuel, both in the fuselage and in the wings. There are no so-called conventional fuel bags or fuel cells in this airplane. The fuel is simply pumped inside the shell of the wing and fuselage structure. So all of that structure had to be absolutely leak-proof. In the inlet duct, each side of the duct provides air to 3 engines. This is one of the longest ducts.
The audience has broken into spontaneous applause as the sleek white Delta Wing aircraft comes to rest.
The inlet duct is one of the longest ever designed into an airplane. It's approximately 80 feet long. Most of the structure in the wings and fuselage is of stainless steel. These are our now famous honeycomb core sandwich panels, and many of the outer skins on these honeycomb panels are as thin as 7/1000ths of an inch. The airplane contains over 20,000 square feet, approximately a half acre of these stainless steel panels. As you circulate around the airplane, you'll note the 6 J93 engines in the after body. Each of these engines delivers thrust in the 30,000-pound category. And yet each engine weighs only 5,000 pounds. One of the novel features of the propulsion subsystem is the capability of continuous afterburner operation in flight. The flight control system is quite novel also. As you walk around the aft end of the airplane, you'll note the elevons located in the wing trailing edge. They operate in unison for pitch control and asymmetrically for roll control. The large twin vertical tails provide directional control, and they are novel in that they have a canted hinge line. The canard, or the horizontal stabilizer up front, is used to trim or balance the aircraft in flight. For takeoff and landing, the elevons are all deflected downward to act as wing flaps. The canard is deflected upward to balance out the resultant nose-down tendency. This enables the Xb70 to take off and land at speeds comparable to today's commercial jet airliners. I'd like to say it's a great pleasure to be here. Thank you.
And now the first close look at the Xb70A. It is almost Cobra-like in appearance. Notice its long, glistening nose and forward control surfaces. As members of the press, official dignitaries, and other observers leave the site, the airplane is again in the hands of its builders, who for the first time have an opportunity to view in full perspective the results of their efforts. The plane is now moved to the final engine test area for a preliminary fitting of the engine noise suppressors. Before the first flight, numerous tests must be performed. These will include proof load tests, ground vibration tests, fuel tank calibration, engine run-up, instrumentation checkout, and finally taxi tests. On the day of the first flight, the Xb70A will take off from Palmdale, following a regular scheduled flight that will terminate at Edwards Air Force Base. And soon, through the flight test program, studies will be made at Mach 3, 2,000 miles per hour, at altitudes of 70,000 feet. Information from these studies will help pave the way towards safe and economical travel in the supersonic transport and the military aircraft of tomorrow. 1964, the most important day in the history of the world's largest supersonic airplane, the Xb70A. Pre-flight crews prepare Air Force 001 for its first flight. Dawn breaks into day. The President and Executive Vice President of the Los Angeles Division of North American Aviation discuss flight plans with Al White, their chief test pilot, the man who will fly the plane. Colonel Joe Cotton, U.S. Air Force, will co-pilot. With him here, the chief engineer on the B-70 project. There are many people working for the success of this flight today. From Mobilcom, flight test engineers conduct on-the-spot communications with the pilots. At Edwards Air Force Base, 30 miles northeast of Palmdale, an Air Force monitoring facility stands ready. A variety of cameras will provide a permanent record of the flight, while skilled pilots in chase planes furnish immediate visual observations. For this first flight, Al White and Joe Cotton will take off from Palmdale, follow a scheduled flight plan, and land at Edwards Air Force Base. They'll put the plane through basic maneuvers, Then, if everything checks out, push on up gradually toward supersonic speed. Total flight time will be about an hour and a half. The primary purpose of the initial flights is to gather data on how the airplane flies, how its new systems perform. One at a time, the 6 giant jet engines are run up to power. Their maximum power output is approximately 200,000 horsepower.
Okay, number 3 now, please.
In the remaining minutes before the plane taxis out for takeoff, it's check and recheck. Each of the aircraft systems and instruments must perform perfectly.
When it's convenient, waits requests a fuel count.
Roger.
8 right, 100. 8 left, 500.
All stations this network, this is Edwards Data Control. Estimated takeoff time for the B-70 is 0830. 0830.
So we'd like to have cockpit readings on pressures.
P1 3750. U1 4150. P1 3750. That P2 4150.
Site 1, will you give us wind velocity and direction too, please?
This is North American Tower. The winds are 090 at 8 knots.
That agrees good with us, thank you.
115. Primary 1 quantity, 2, 5. Switching to primary 2 and utility 2 fluid levels.
Advise hydraulics now disconnected.
Roger.
Presently closing the cockpit door.
Palmdale Tower, 001, how do you read?
Good morning, 001 Palmdale Tower, is you loud and clear.
Roger, we're ready to taxi.
Roger, cleared to runway 7 via taxiway Bravo, wind 090 at 8. Cleared for takeoff when ready.
Roger, thank you. And we're rolling out.
Roger, now, good luck.
The Xb70A represents a new concept in aircraft design, not only in appearance, but in its specifications as well. Speed, 2,000 miles per hour. Altitude, 70,000 feet. And a range that will span continents.
Multiple chase 2 and 3,
Several Air Force and North American officials arrive at the Edwards Flight Monitoring Facility to watch the plane's progress on a closed-circuit television system.
Al, this is Data Control. We have you on the TV monitor and you look great.
Overcom monitor waits reports all okay as is. Roger, monitor. Attention all stations, this is Mobilecom 001, now lined up on the end of the runway. Takeoff will be to the east.
Chaser, are you all ready?
Hey, sir, give us a phone.
Got 1 minute now. Seconds now. Data on at 7825. Coming up on power. 10 seconds. 20 now, coming through 6,000 feet. Coming out of AB now. All engines at naught, sir. Okay, Chase, I'm going to give you a countdown, and we'll take data, and we'll blow a gear up. Roger. You ready, Chase? Yes, sir. 3, 2, 1, gear up now.
Handle up. Stopped is not holding.
Okay, they are static, is that right? They're not moving?
That's correct.
Okay, I want a confirmation from the ground to go ahead and put the gear handle back down.
Roger.
Let's go ahead and put the gear handle back down. On the countdown, 3, 2, 1, now.
Handle.
When the gear handle was put down, the landing gear returned to its normal extended position. It was determined that a faulty electrical switch had caused the malfunction.
Get around headed northeast again so that I can make a straight run for 3 minutes.
Roger.
I'm holding 254. Right now, 14,850. Got 100% on all engines. What's your total fuel, Joe?
67,000. Primary 2 fluid level, 205. Utility 2 fluid level, 205. Going to the primary 1, utility 1, and they were holding fine. Primary 1, 205. Utility 1 is coming back. I'm quite sure it'll steady at 160, and it is. Fluid levels are fine, status indicators are okay, and pressures look good.
I shut down number 3 engine. I got an indication it's starting to go over 108%. That could have been an indicator, but I couldn't take the chance. I shut it down.
Loss of an engine in this airplane is no problem, and the flight continues successfully with only 5 engines operating.
We're burning up quite a little bit of fuel. I think I'm going to knock this off at the end of this one and do the low speed and come in and start some landings.
Roger, understand.
I'm going to put the flaps down. I'm going to just slow the airplane down if you'll give me a landing speed.
Minimum touchdown speed will be 175 at your present weight, Al.
I'm going to come down and make a go around the pattern.
Roger.
Al, 194 on the approach speed, 184 on the flare.
Hello, Edwards Tower, you're reading 001.
001, Edwards Tower, loud and clear.
Turning into final approach for a low-go.
01, Roger. The Edwards winds are variable 020 degrees at 10.
Roger, thank you.
Al, you're going to make a go around this time, is that right?
That's affirmative. Hey, I can see that shadow now. That looks pretty good.
That big long one's you. 4 is empty and it's off. I'm going to 2.
Roger.
$45,000, and we're going to land out of this one.
Roger.
Chase, if you obviously see me leveling off a little high, well, let me know, huh?
Hey, firm. I'll give you a countdown for about 50 feet.
Okay.
Shoes up 1 knot.
You heard the jettison. Jettison.
Jettison. Jettison now, 74.
Your aft tires are blowing and they're both burning, but not very badly. You've got 3 fire trucks with you.
A locked brake caused the 2 rear tires of the left-hand main landing gear to blow out. The pilot and co-pilot heard the tires blow out, but were unaware of any damage and had no difficulty in bringing the plane to a perfect straight-line stop.
Which set of tires was it that blew?
A first-hand report on how the flight went was given to the press by Warren Swanson and Al White of North American, Brigadier General Irving L. Branch, commander of Edwards Air Force Base, Colonel Joe Cotton, the project pilot, and Colonel Marion Akers, program director of the B-70 Systems Project Office.
General Branch, would you like to go ahead and give some introductory remarks and then start from there?
Anytime we fly an aircraft out here, it's a big event, and this, of course, is one of the most important events we've ever had because it's the first of the truly triple-sonic aircraft, which will be a major part of the national inventory in the future. This marks a milestone in our work here, and I'd like to turn this over to Al White, the pilot, to have him say a word or two.
And I'm very delighted with the way the thing went today. I think mainly because after quite a long wait, we're now on the way to developing this airplane and getting into this flight test program from which we have so much to gain. We took off with an intent of flying around the base here until we were satisfied that the airplane was performing satisfactorily. We had a good look at all the systems. Everything looked like they were okay. And we at that time attempted to bring the landing gear up.
I think maybe you'd circled the lake once about then. Then he made a normal gear retraction, and it did not fully retract, so it was decided not to fool around, to take all the precautionary measures possible and just put the gear back down and leave it in that position, then proceed to the alternate flight plan to obtain our test data that we wanted with gear and flaps down and with flaps up.
I shut one engine down because we had a malfunction in that one, but had absolutely no trouble handling the airplane with the one engine out. Came on down and took a look at the approach, made a low go around, which was planned, and came on around for the landing. And I think that both Joe and I are very happy with the way the airplane was controlled. Had no problem with the landing, no problem with its visibility, and a lot of the things that we've been thinking that there was some question about, and I'm just real tickled with the way the thing went other than the malfunctions. We're disappointed in that regard naturally. The indications are that the rear axle on the left bogie was locked when we touched down and didn't unlock at all, and it blew the tire and ground the wheel down. We had some malfunctions, but boy, that's why I got this job. If we never had any malfunctions, there wouldn't be any test pilots. I'm delighted with the whole thing. As I said earlier, this is the big step in getting us on down the road. We've flown now, and we're going to keep on flying, and we're not in the stage of waiting anymore.
2 weeks after its initial flight, the Xb70A is airborne again. Changes were made on the landing gear brake system to prevent locking. A faulty switch which prevented gear retraction was replaced, and the number 3 engine overspeed condition was remedied.
Okay, Chase, I just about got my speed. Is everybody in position?
Roger.
Okay, let's have the data on and the counter number, please.
Data on continuous 3370, time 32 and 10 seconds.
Okay, Chase, here we go with the gear on the count. 3, 2, 1, gear up.
handle up. There's an opening. The green lights are out. It's good. Nose gear is up and door locked. Going in real well. And both main gear doors are coming closed, and they're closed, and it looks clean now. Okay, I'm going to make a left turn here and head back a little bit.
Roger, you're clear to the next point.
Okay, data on, please. There's your pitch pulse.
Roger.
Roll pulse. Some holding 32,200.
Roger, Joe. Total fuel.
100,000 pounds.
Roger.
So we're losing utility number 1.
Roger, gear down as soon as possible.
Pressure is dropping in the utility hydraulic system due to a cracked braze in the hydraulic line.
260 knots, the gear's coming down.
Coming out on the main gear unknown.
The Xb70A has 4 independent hydraulic systems. The landing gear operate from 2 utility systems. If utility hydraulic pressure is lost, as was indicated, the landing gear is lowered by the remaining utility system as soon as possible. This is a precautionary measure.
I got 3 greens and no red.
Plan to land on the South Lake bed headed north.
Wind 300 degrees at 2.
The decision is made to land on the 11-mile-long lake bed runway, which will allow ample length to stop without braking if necessary.
170.
We're down and flaps down. The indications are green all the way.
More valuable flight data was obtained during this flight, and the speed and altitude were doubled. The troubles encountered on the first flight have been overcome. Brakes, nose wheel steering, drag chute, all performed perfectly.
All stations this network, the B70 is taxiing out from the run pad. The B70 is taxiing out from the run pad.
Just a week later, the third flight was underway. The goal? Supersonic speed.
001, as you turn at the base of the tower.
By now, the pre-flight checkout continues without interruption. It has become almost routine for these men, whose job it is to fly and test Air Force 001.
Let's take a look at those hydraulics.
Various flutter and stability tests are made as the plane climbs in speed and altitude. All systems are performing well.
Al, we might be more efficient here if you'd light the AB.
Roger, data on. Roger.
What's your Mach number now, Al?
At 1.1, at 35,100. Boy, that do go now.
Roger, Mach 1.1 at 35,100 feet.
At a press briefing held after the flight, Al White recounted,
One of the significant things about this flight was that we went supersonic, in fact, 3 different times. The airplane goes through the sound barrier like all other present-day supersonic airplanes. There isn't a trim change nor anything to indicate that you've gone supersonic other than your flight instruments. We flew roughly 20 minutes at supersonic speeds, and systems-wise, the airplane performed just beautifully today.
This was the first time Joe Cotton had an opportunity to fly the airplane. From the co-pilot's viewpoint,
You see, the major systems are also very important to get the aerodynamic information that we're after. Today, the electrics, hydraulics, fuel system, environmental, not one squawk.
the slightly mottled Dalmatian appearance resulted from some loss of paint during this flight.
I'm descending through 23.5 now.
Final approach speed 194, flare speed 184, touchdown 168, 168.
Roger.
001 Edwards Tower. Winds are presently indicating calm.
All stations, the B-70 will land out of this approach. The B-70 will land out of this approach.
The third flight in 3 weeks, an exceptionally good record for a new airplane. All test objectives were met. There were no systems failures or malfunctions. Just one note of discord. Some additional paint was lost. It was determined that in certain areas it had been applied too thick. It became brittle, and when the structure flexed, some paint broke and peeled off. The success of the flight is reflected in the faces of everyone. Flight number 4. 2 primary goals. Fold the wingtips down, reach a higher supersonic speed. This time, Mach 1.4. Landing gear and flaps were retracted immediately after takeoff, and 001 climbed to 35,000 feet and a speed of 0.95 Mach.
And we're just about over Harper's at 95. But I'd like to go ahead and put the wingtips down here. Roger. The wingtips going to 1/2.
In supersonic flight, as an airplane increases its speed, a smaller wing is required. At the same time, a larger vertical tail surface is needed for improved directional stability. On the Xb70A, this is achieved by its folding wingtips, a first for the aviation industry. As planned, the tips were folded down 25 degrees. Succeeding flights at higher speeds will be made with tips down 65 degrees.
1.4. Well, this thing really wants to accelerate here. Data on. How do those wingtips look?
They look good and solid, Al. Engine's good, hydraulics good.
Mach 1.4 at 45,000 feet. This 4th flight concludes the first phase of flight testing. In reviewing the flight for the press, co-pilot Joe Cotton remarked,
The wingtip operation went off as really slick as a whistle, and she was really born to fly with the tips down.
In just 34 days, 4 test flights have been conducted, 2 of them at supersonic speeds. In the words of Al White,
We have now not only just gone supersonic, but we've pushed on up there a good big step, and we're looking forward to going ahead in equal size steps on up to Mach 3.
it is these future tests which are expected to prove many of the new concepts of design and materials which have been incorporated into the Xb70A.
Building the first Xb70A had been a challenging job. New fabrication and assembly techniques, revolutionary electrical and hydraulic power systems, and advanced instrumentation all had to be developed. Above all, the mission required a totally new aerodynamic design, a design that may be the key to man's future conquest of his own atmosphere. But the flight test of this supersonic giant presents even more dramatic challenges and more dramatic achievements. With North American's Al White at the controls and Colonel Joe Cotton as co-pilot, the first liftoff occurred on September 21st, 1964. The first 3 flights demonstrated excellent low-speed handling characteristics. Stability and flutter tests proved the basic soundness of the design. The pilots were well satisfied with the plane.
And I think that both Joe and I are very happy with the way the airplane was controlled. Had no problem with the landing, no problem with its visibility, and a lot of the things that we've been thinking that there was some question about, and I'm just real tickled with the way the thing went.
On the 3rd flight, the aircraft broke through the sound barrier 3 times.
Boy, that do go now.
Progress toward Mach 3 had begun. The wingtips were lowered 25 degrees for the first time on the 4th flight. Moving these 500-square-foot wingtips is a major achievement. The first time such a large structural portion has been repositioned in flight. With the tips up, the Xb70 retains its superior subsonic handling qualities. Lowering them provides stability at high supersonic speeds, reduces trim drag, and reinforces compression lift effects. Phase 1 testing was completed in 34 days, with 55 minutes logged above Mach 1. Total flight time, over 5 hours. Next on the schedule was a complete proof loading. Controlling and stabilizing surfaces were loaded to their limits. Deflection was as predicted, and the surfaces met all requirements of high-speed flight. After thorough proof loading, the plane was ready for Flight 5, the start of Phase 2 tests.
We'll put the wingtips down on 3, 2, 1, now.
Tips look real steady.
With the tips full down, 65 degrees for the first time, the plane shot to a new high speed, Mach 1.6. Supersonic flight with folded wingtips soon became familiar. They are moved down 25 degrees at 0.95 Mach and to full down at Mach 1.4. The design innovation is completely successful. As Colonel Cotton remarked,
She was really born to fly with the tips down.
after decelerating, engines were shut down and restarted. There were 2 restarts made at Mach 1.4. Another was made at a lower speed.
Okay, starter up, Fitz. Air start is on. Count 5160, throttle coming to idle.
Inlet ducts, bypass doors, and ram air scoop were successfully operated. But speed and altitude highs, Mach 1.85 and 50,000 feet on the 7th flight, are only the most obvious measures of achievement. The Xb70A is not only a new aircraft, it's an airborne laboratory, a chance to gain information which will prepare the way for the airplanes of tomorrow. During flight, ground recording devices include a continuous telemetered record of 36 key information channels. These allow procedures to be varied to make sure all test information is gathered.
What's your Mach number now, Al?
1.1.
After the flight, a graphic record is provided by 100-channel recorders. 2 magnetic tape reels bring back the bulk of this information. 90 million individual measurements from nearly 800 separate sources throughout the plane. The final results are reduced by computers and high-speed printers to simple, readable form. Bit by bit, volume by volume, an invaluable reference encyclopedia of sustained supersonic flight is being compiled. The airplane has demonstrated its ability to transcend flight problems as well. Flight 9, for example, was shortened after a pressure drop in the utility hydraulic system. The landing at Edwards Air Force Base was the heaviest ever recorded. With the plane weighing 419,000 pounds, it was more challenging than an aborted takeoff test. All systems performed well during approach, landing, and rollout. Hydraulic problems, which had also occurred on flights 2 and 6, were later solved by replacing the rigid steel tubing with newly developed flexible tubing in specified areas.
Hydraulics good, all pegged, 205, looking good, hydraulics.
The windshield ramp was moved to the up position for the first time during the 10th flight. This reduces drag and turbulence at extreme supersonic speeds. With the wingtips full down and the windshield ramp up, the Xb70 assumed its Mach 3 aerodynamic configuration for the first time. More than 50 minutes of the hour and 40-minute flight were spent at or above Mach 2. Top speed was Mach 2.3. As the plane moves beyond Mach 2, the advanced inlet design becomes of paramount importance. In order to cruise at up to 2,000 miles an hour, the shock wave must be brought inside the 80-foot-long inlet and automatically positioned by movable ramps and bypass doors. A continuing series of successful inlet duct tests was begun on the 8th flight. More important, the inlet duct was repeatedly unstarted above Mach 2, forcing the shock wave out, then easily restarted. The airplane left the Edwards runway on its 12th flight, weighing more than 500,000 pounds, a new weight high. Inlet duct tests had been performed, and flight objectives of Mach 2.6 and 65,000 feet had been reached when, after 30 minutes above Mach 2,
I got very high engine vibration.
And 30 seconds later,
Give me a heading home. Right. 210, 210.
the landing on the lake bed with only 4 engines emphasized the plane's ability to withstand totally unforeseen conditions. A small piece of stainless steel skin from the apex of the wing had been ingested into the right duct, damaging engines 4, 5, and 6. The apex section was later revised to prevent a recurrence. The airplane moved close to its design goals, Mach 3 at 70,000 feet, on the next 4 flights. The 15th flight was typical of these threshold missions, designed to test the plane's response to sustained high-speed cruise before proceeding on to Mach 3. Temperatures become vitally important as the plane cruises at speeds and altitudes never before invaded by such a giant aircraft. Though the air outside is thin and cold, the plane's skin temperatures build up as speed is increased, placing great demands on structure and control systems. On the 15th flight, at 66,000 feet altitude and a speed of 1,900 miles an hour, the plane experiences heat soaking in a temperature of more than 500 degrees for 20 minutes. The biggest single barrier to Mach 3 flight, heat, has been overcome. Through the 16th flight, more than 23 hours had been spent in the air, more than half that time above the speed of sound, including 6 hours of cruising above Mach 2, and more than 1 billion individual measurements taken for NASA and Air Force research projects.
5, 4, 3, 2, 1, brake release.
Each of the 6 J93 engines produced by General Electric is capable of delivering 30,000 pounds of thrust and will produce approximately 200,000 horsepower at Mach 3 and 70,000 feet. On its 17th flight, the airplane achieved its initial goals: speed in excess of Mach 3 and altitude of 70,000 feet.
Oh, there's that big magic number, boy. That's a boy. Congratulations to both of you.
This was accomplished in less than 25 hours of total flight time and just over 12 months after the first supersonic flight. The Xb70A has achieved these goals without any aerodynamic changes required. This in itself is significant and becomes even more so when the revolutionary firsts, such as the multi-shock air inlet duct, the canard delta wings, and the folding wing tips are considered. Information obtained in the Xb70's progress to Mach 3 will provide further understanding of the operational problems associated with flight of a large supersonic aircraft and will contribute to this nation's program to develop a successful supersonic transport. The date was October 14, 1965. It was appropriate that the 2 men most involved in flight testing the Airborne Research Laboratory, North American's Al White and the Air Force's Colonel Joe Cotton, were at the controls when the Xb70 attained its magic number.
Congratulations, buddy.
Congratulations, Al.
Thanks a lot, Joe.
All the way. I won't forget to say that.
Thank you. Congratulations.
Thus, the result of the Xb70 flight test program to date is not only a series of record-setting achievements, it is a significant milestone in the history and the future of manned flight.